All right, welcome back. This is going to be the Module 4 homework demonstration. And for this one, we're going to go through two proofs from the book, a relatively simple one to begin with, and then one of the more complicated ones at the end of the book. So if you want to take a look at this and have it by your side while you're trying out the proofs and the homework, it'd probably be useful. Okay, here we go. Here's the first one. This is one of the simpler ones. We got if C, then T, then L, not L, and then not E, if not E, then C, and then L or not E, and then our conclusion is not T. Now, if this was, naughty. If this was if this was done with truth tables, it would be an extremely long proof. You would have, well, how many letters are there here? We've got C, T, L, and E. So, this would be very long and it would take forever, but we're going to do it through natural deduction. It's a little bit more intuitive, and you're going to see how one piece leads to the next. So let's start with, we need to start generating some premises. We can generate a premise using any of the rules that that are valid. So in this case, it looks like we have, notice premise 2 here and premise 4. We've got L or not E, but we already know that not L, right? So L is false, which means for this or statement, since only one side can be false, one of the sides has to be true, and we know it's not this one, right? Because not L, L. So that means that the not E has to be true. So then we get not E through disjunctive syllogism on 2 and 4. So that we're off to a start. So then we've got the not E. You take a look at premise 5 and then premise 3. Notice if not E, then C, and we have not E, which means we can use modus ponens to get C by combining these two. Now, if you look at this, you say, well, how many premises do we have now? There's actually now 6 premises. We've created 2 new ones. Now, the reason we're doing this, remember, is we're trying to create a premise that is identical to the conclusion. We're trying to create not T as a premise. So far we've got not E, and we've got C. So now let's see if we can create another one. If we've got C, take a look at number 1 here. So 1 and 6. So if C, then T, then L, and we actually have the C. See that? Which means that we can get if T, then L through modus ponens on 1 and 6. Now, if you notice, we're getting very close to the conclusion. We're trying to get not T, and we've got this. Like, you should start to, at this point, you should start salivating a little. Like, we're very close to the conclusion. Like, you should be able to taste it. Like, if you were the lion and you were hunting down a zebra, and like at this moment you can sort of smell the zebra. It's so close to you, right? You're close. So you've got T, then L. We're trying to get the not T. So we would need not L to do a modus tollens. And you notice we already have not L here on 2. Now, we already used 2 over here in order to get 5, right? Since we did a DS on 2 and 4. So can we still use 2? Of course. It's always live. It's always available, just like the Sudoku puzzles. So we've got now not T using modus tollens on 2 and 7. Right? And now that we've got the not T, then we declare victory. We're done. We've created a premise identical to the conclusion in every way. It is exactly the same, no differences at all. And so therefore we've proved that this argument form is valid, that no matter what our values for C, T, L, and E are, whatever they are, as long as the premises are true, the conclusion will be true as well. So it's a relatively simple one. 4 steps using only the rules for inference. Now for this next one, we're going to do a proof that requires not only the rules of inference, but also the equivalence rules, the replacement rules. So let's take a look at that one. This is number 17 from the section called longer proofs, or the final set of proofs. So here we've got only 2 premises, C, A, and B. And we've got not C, and then our second premise is not A and B, or not A and C, one of those 2. Now, a problem like this, we're trying to get B out of this. It's not entirely obvious how you should proceed. So one of the things that you could do is strategize. And when you're doing strategy, I suggest working backwards from the conclusion. So we need to get B somehow. Now, if you look at all of this, there is a B. It's right here. So if you somehow could get this statement, this part of the statement out by itself, if you could somehow manage that, then you could do a simplification on it to get B. Right? Since not A and B are both true, then B is true. But you would have to get this part here by itself. Okay? So let's just imagine, if I had this, not A and B, then we'd be in good shape. Now I could get this side. Remember, notice this is in an OR statement. Right? This little piece here is one half of an OR statement. And in an OR statement, you only need one side of it to be true. And in fact, if you find out that one side of it's false, that means that the other side has to be true. So in order to get this to be by itself, to be true, we would have to somehow show that this side here is false. So if we could find out that this was false, then we would know that this part was true. And if this part was true, then we could simplify the B and get the conclusion. So we somehow have to get not A and C. All right, we need to somehow find this. Not A and C. All right, well, how could we get that? Well, you notice this statement here, this not A and C, it's got this not in front of a parenthesis with a dot in it. You can use De Morgan's rule on this to remove this not and change this into an or statement. So if you go look in the book, you might if you want to, just pause the video right here. Go take a look at the book under De Morgan's rule, and you'll see that this is the equivalent of this statement. A or not C. Right? So this statement and this statement are the same through De Morgan's rule. So if you had A or not C, you could De Morgan it to get this. Right? And then you could use this with number 2 in a disjunctive syllogism to get this side. And then you'd be able to do a simplification to get the B. All right, well, now we've got a little bit of strategy here. We notice there's a C, a not C here. So this is already available to us. So I think now we can figure out what to do next. So the first step that we should take is to add A to not C. Not C or A. And if you have that, then we have a start. We're trying to get to this point. Well, now, if you have an or statement, you can simply reverse the two statements. You transpose the two sides of the or statement because either one is true. It doesn't matter the order. That's the rule of commutation. So you use commutation on 3 to get A or not C, and then here we are. We're now on the path towards the end. And we said once we get this, we would De Morgan it, right, in order to get this next statement, not A and C. Then from there, once we have it De Morgan, we notice this is not this half of number 2, which gets us not A and B, disjunctive syllogism on 2 and 5. And at this point, like I said, you're there at the end. You've discovered what you're looking for. You're on the hunt for the zebra as the lion, and you're extremely close. And so now you have to just take the final step, doing a simplification on 6 to get B all by itself. And B is the same as the conclusion. We've created a premise that is identical to the conclusion, which means that if these premises are true, then this premise, the conclusion, has to be true too. So enjoy the zebra steak. These proofs are kind of tricky, require some patience and creativity. If you get stuck, don't worry. Keep working at them, use the homework forum, and we'll all get through this module.